Hello, hello. I got a pop quiz for you. In a previous lesson, I defined the word entropy. Do you recall what that was related to? I don't expect you to have that memorized yet, but if you do recall, you have a great memory. Think of entropy as a fancy way of saying randomness. The more random a key is, the harder it is to guess or crack. But when users create passwords, they tend to go with things like password 123 or their dog's name. That's low entropy, and it's a problem. So how do we strengthen those weak human-generated inputs? We use salting and key stretching. If you recall, when we hash a password, we're using a one-way function. That means you can't reverse a hash back into a password, which is great. But a hacker can still brute force it. All they have to do is just guess tons of passwords, hash them, and see if they match. And that's where salting comes in. A salt is a unique random value added to each user's password before hashing it. This means even if two users pick password 123 as their password, their final hash would be totally different because the salt is different. The salt isn't secret, but it forces attackers to rehash every guess using the specific salt for each account. That makes pre-computed attacks like rainbow tables practically useless. The idea behind key stretching is to take a password and make it more secure by processing it through thousands of hash iterations. It doesn't make the password stronger, but it makes brute force attacks painfully slow. I mean, imagine trying to guess a combination, but every guess takes 3 seconds instead of 3 milliseconds. That's what key stretching does. It's built into libraries like PBKDF2. A technology that uses PBKDF2 is Wi-Fi, WPA. Bottom line, more time per guess equals fewer guesses, which means better security. Alright, let's switch gears and talk about obfuscation. Instead of strengthening the password, what if we make the data harder to spot? I mean, that's where obfuscation comes in. Think of it as hiding data in plain sight. You've got steganography. This means hiding a message inside something else, like embedding a secret message in an image file. The message can be encrypted first for added security. Used the right way, it can prove a file's authenticity or origin. And then you have data masking. This is where we blur or redact the sensitive part of the data. You've seen this in action. For example, this type of credit card with asterisks except for the last 4 digits. Or a phone number doing the same thing with asterisks except for maybe the last 4 digits. Masking lets you use or analyze data while keeping private details safe. It can also preserve formats so your software doesn't break. And then you have tokenization. This method replaces real data with a random token, like swapping a social security number with a random string. The original data is stored separately in a token vault. This is reversible, but only if you have proper access. Tokenization is often used in payment systems and is a popular alternative to encryption because some regulations treat encrypted data like it's still sensitive, while tokenized data can be considered de-identified. Both data masking and tokenizations are a form of de-identification. The goal is to strip personal details from datasets so they can be shared, like for analytics or research. All this without putting anyone's identity at risk. Alright, that's all for now. Here's a recap. We learned entropy means randomness. More random keys are harder to crack. We also learned about salting, how it adds a unique random value to password before hashing to prevent pre-computed attacks. We learned about key stretching, how they run passwords through thousands of hashes to slow down brute force attacks. We learned about obfuscation, hiding data to reduce risk. And we learned about steganography, hiding messages in files like images. And data masking to replace parts of data with asterisks like credit card data. And we learned about tokenization, how it swaps real data with random tokens, storing original security. And lastly, we learned about de-identification, how it removes personal details from data for safe sharing. See you in the next one.